Here is the question that I ended the last part of this lecture with, and this is really checking your understanding of the conventions that we're using in this course, in particular the way I am drawing systems. So remember that I have told you we are always going to define a system as a list of objects, and we will never allow an object to enter a system or leave our system. And so in particular, in this case, that means we can't be saying that the water here is entering the system or leaving it. And so I have defined my system in this diagram as just the scallop. And note that if I had decided to redraw my system boundary box here, I would have had a lot of trouble drawing it in a way that would still show that the scallop was in my system but the water wasn't, which is why I'll tend to only draw it once, in whichever picture is easiest to draw it and show the system. Once you've defined your system, the system probably has some quantities which are measurable. For example, we could talk about the total inertia of our system, the total amount of matter in our system. That's certainly a measurable quantity, which is a property of our system as a whole. Now, the way certain quantities behave is very convenient, and it's worth being aware of them. So the quantities we're going to be mostly concerned with are things that we call extensive quantities. And the basic definition is that the value of an extensive quantity is proportional to the size of the system. The term extensive comes from the fact that you could think of size as being the extent of the system. And so this is a quantity that is proportional to the system extent. Well, this may not be meaningful to you yet. I'll proceed by some examples which should make it clear. But let me set up how you test whether a quantity is extensive. Let's say we have a system. So that yellow oval is our system. And there's some quantity Q that's a property of the system as a whole. What happens if we divide our system into two pieces? I don't mean literally chopping it in half, but perhaps we decide instead of thinking of it as one system, we instead think of only a part of it, and now the other part is part of our environment. Well, if the system, if the quantity we're thinking of, Q, is extensive, then the total Q for our original system is just the sum of the Q's for the parts of the system. Similarly, if we start with two systems and we mash them together, or rather than actually physically combine them, think of them as a single system instead of two separate pieces, again, the value of Q for the total is the sum of Q1 and Q2, if Q is an extensive quantity. So let's look at an example. And I've been realizing, looking around at the internet, that there's something missing from these videos. Clearly, if you look around at the internet, there must be some regulatory body that makes sure that everything on the internet meets some quota of cat pictures. So we need some cat pictures, and I'm going to construct this example around cats. Otherwise, the internet police will come and, remove these videos. So let's think about two houses, and there are people living in these houses, and these people have cats. Well, we can think of each house as a separate system, and we can count the number of cats in each house. We can also think about the pair of houses as a single system, and I think it's fairly obvious that the total number of cats in the two houses is just the sum of the number of cats in the separate houses. And so this is following the rule for an extensive quantity. The number of cats is extensive because when we combine two systems, the number of cats is just the sum of the number of cats in the individual parts of the system. Well, what about something that isn't extensive? So, for example, we could talk about the time per day that our system is occupied by cats. And let's say, to keep things simple, that these are all indoor cats and the people living in these houses are keeping them inside. So, In that case, the number of hours per day that each of these houses is occupied by cats is 24. But now if we think of the combined system, well, clearly the number of hours per day that the combined system is occupied by cats is also 24, and that is not the sum of the values of this variable t for the individual parts of the system. So the time per day that there are cats in the system is not an extensive quantity because it doesn't obey that additive rule that all extensive quantities have to. The idea of extensive quantities will be central to much of the rest of the course, and so let's make sure you've got the idea. So let's keep thinking about this system of two houses containing cats, and I've listed 5 quantities, and I want you to decide which of these 5 quantities are extensive. It's possible that more than one of these is extensive.